Hi, students and friends, host and teacher Sayyid Ayazuddin Haider, and you are watching Learn and Teach by Sir Ayaz. So I was doing the past papers 0620 and I'm done till 42. This time I have selected 43 and it's of May-June 2023. So let's start the paper. Question number 1. Some symbol equations and word equations A to J are shown. In A, it's a neutralization reaction. In B, it's a precipitation reaction. In C, it's a substitution reaction. In D, it's an addition reaction. In E, it's a cracking reaction. In F, it involves displacement reaction. In G, it's incomplete combustion reaction. H is a formation of ester or esterification. I is the reaction between hydrogen and oxygen to produce water. And the last J, it's the reaction which involves the formation of glucose during the photosynthesis in plants. Use the equations to answer the questions that follow. Each question may be used once, more than once, or not at all. Give the letter A to J for the equation which represents A, photosynthesis. I have just mentioned that J is a reaction for photosynthesis. This is the reaction between carbon dioxide and water to produce glucose and liberate oxygen. So J will be the right answer for A. B, an addition reaction. If you look at all these reactions, one of the reaction involves the addition reaction. And addition reaction is common in alkenes. So we have alkene here in D, propene, propene plus bromine, and we are getting only one product after the addition of bromine to propene, that is 1,2-dibromopropane. So D will be the right answer for B. Number C, a precipitation reaction. Precipitation reaction involves the formation of insoluble solid in the solution. So in choice B, you can see it's a reaction between Cr3 plus and 3 moles of OH negative ion to produce solid precipitate of chromium 3 hydroxide. This is chromium 3 hydroxide. So all the hydroxides are soluble. We have few exceptions, that's group 1 and from group 2, especially the metals in group 2 below in the group. Fine. So B will be the right answer for number C. D, incomplete combustion reaction. Incomplete combustion reaction involves the reaction between organic compound and oxygen, which is also known as burning, and the product produced is carbon monoxide and water. You can clearly see in G that methane is reacted with oxygen and products are carbon monoxide and water. So G will be the right answer for number D. E, a displacement reaction. A displacement reaction involves the reaction between a highly reactive element with the compound of the less reactive element. So in F, you can see there's a reaction between chlorine and aqueous potassium bromide. Look at the position of chlorine and bromine. Here they are in group 7. In group 7, the trend is reactivity decreases down the group, which means the halogens at the top will be able to displace the halogens below them from their compounds. Here they are asking about chlorine and the compound of bromine. So definitely this will be the right answer for this F. Last one, F, a substitution reaction. A substitution reaction involves the displacement of one atom in organic compounds, and it is common in alkanes. So C is the example of this displacement reaction. You can see the reaction methane is reacted with chlorine and the product is chloromethane and hydrogen chloride, which means one of the hydrogen in methane is displaced by one of the chlorine atom to produce chloromethane and hydrogen chloride. So C will be the right answer for this part. Moving to next question. Number 2A. The symbols of the elements in period 3 of the periodic table are shown. Here we have symbols of period 3 elements. We have Na, sodium, Mg, magnesium, aluminium, Al, Si, silicon, P, phosphorus, S, sulfur, Cl, chlorine, Ar, argon. Here we have period 3. This is period 3. Starting from sodium and ending on argon. Use the symbols of the elements in period 3 to answer the questions that follow. Each symbol may be used once, more than once, or not at all. Give the symbol of the element that, number 1, is present in purified bauxite. Bauxite is the compound of aluminium. So aluminium must be present in purified bauxite. Al is the answer. Number 2, contains atoms with a full outer shell of electrons. So we have only one element in this period that has full outer shell of electron, that is argon. Ar is a symbol. Number 3 is used to kill microbes in water treatment. Chlorine is used to kill microbes or bacteria during water treatment. So Cl will be the answer for this question. Number 4, forms an amphoteric oxide. We have only one element that forms amphoteric oxide here, and it is aluminium. So Al will be the answer for this one. Number 5, forms an oxide which causes acid rain. So acid rain is produced when non-metal oxides are released in the air. It can be either oxides of phosphorus, sulfur, or chlorine. The main culprit or most of the gas which is produced in the environment and is responsible for the acid rain is oxides of sulfur. So you have S as the correct answer, but you can write Cl or P also, because if the oxides of chlorine or phosphorus is released in the environment, they will also cause acid rain, as these oxides are acidic. Number 6, has an oxidation number of -1 when it forms a compound with hydrogen. So it has an oxidation number of -1 when it forms a compound with hydrogen. So look at the position of all these. So we have only one element that will be in group 7, which has oxidation state of -1 when it forms a compound with hydrogen. The compound will be HCl. So automatically answer will be Cl for this part. Moving to next part, B. The relative atomic masses of elements can be calculated from the relative masses of isotopes and their percentage abundances. Number 1, identify the isotope to which all relative masses are compared. It's carbon 12. So you'll write carbon 12. Number 2, table 2.1 shows the relative masses and the percentage abundances of the two isotopes in a sample of magnesium. So we have relative mass of isotope 24, its percentage abundance is 85, and another isotope, it has relative mass of 26 and relative abundance is 15. Calculate the relative atomic mass of magnesium to 1 decimal place. So what we will do, we will multiply 24 by the percentage abundance, that is 85, plus 26 will be multiplied by its percentage abundance, which is 15 here, and this will be divided by 100. So 24 multiplied by 85 gives 2040 plus 26 multiplied by 15 and we'll get 390 divided by 100. So 2040 plus 390 divided by 100. The answer is 24.3. C. An ion contains 10 electrons, 13 protons, and 14 neutrons. Number 1, state the nucleon number of the ion. In order to get the nucleon number, you simply have to add up these two values, protons and neutrons. So 13 plus 14 gives 27. Number 2, identify the element that forms this ion. Look at the proton number. Proton number is 13. So where will we find this? Here it is. It must be aluminum. Proton number is 13 and it has formed ion with 10 electrons as it is a metal. So you'll write Al or aluminium. Question number 3. Magnesium forms ionic compounds. A. Magnesium reacts with fluorine to form the ionic compound magnesium fluoride. The electronic configurations of an atom of magnesium and an atom of fluorine are shown in figure 3.1. Here is magnesium atom and here is fluorine atom. Figure 3.1. Number 1, ions are formed by the transfer of electrons from magnesium atoms to fluorine atoms. Complete the dot and cross diagrams in figure 3.2 to show the electronic configurations of one magnesium ion and one fluoride ion. Show the charges on the ions. So first of all, you should know how many magnesium and fluorine atoms are involved during this transfer. We have magnesium and fluorine. Magnesium belongs to group 2. Here is magnesium. Group 2 carries +2 charge. Fluorine belongs to group 7. It carries -1 charge. So +2, -1. Ignoring the charges, these are subscripts. These subscripts will be exchanged. And the final formula will be MgF2, which means that there will be one magnesium atom involved during the formation of magnesium ion and 2 atoms of fluorine involved in the formation of fluoride ions. One magnesium atom will donate 2 of its valence electrons. What is the proton number of magnesium? It's 12. After losing 2 electrons, it must have 10 electrons left. So this is the electronic configuration of magnesium. 2, 8, 2. After losing 2 electrons, it will be left with 10 electrons. That is 2, 8. And it will acquire +2 charge. So I'm going to show the 8 electrons in its second shell. They have already shown 2 electrons in the first shell. So here we have second shell. 1, 2, 3, 4, 5, 6, 7, 8. And it has lost 2 electrons, so it will acquire +2 or 2 plus charge. What about fluorine? Each fluorine atom will be receiving 1 electrons. So here's fluorine. What is the proton number of fluorine? Here is fluorine. Proton number of fluorine is 9. Electronic configuration of fluorine is 2, 7. So after gaining 1 electron, it has 8 electrons now in the valence shell and it will acquire minus charge. So I'm going to show 8 electrons in its valence shell. 1 electron will be coming from magnesium atom. So here are the electrons of fluorine first. 1, 2, 3, 4, 5, 6, 7. And the 7th electron coming from magnesium atom. So it has gained 1 electron. So I have to place minus charge. Number 2, deduce the formula of magnesium fluoride. I have already done this on the left hand side. So you'll write MgF2. This will be the formula for magnesium fluoride. Number 2, when solid magnesium fluoride is dissolved in water, it forms a solution that conducts electricity. State one another change that can be made to solid magnesium fluoride to allow it to conduct electricity. It must be in the molten state. So you have to heat it or melt it or molten state. Heat it or melt it or in molten state. Moving to next part. B, silicon tetrachloride SiCl4 and silicon 4 oxide SiO2 are covalent compounds. Complete the dot and cross diagram in figure 3.3 to show the electronic configuration in a molecule of silicon tetrachloride. Show outer shell electrons only. You need to show only outer electrons. So first of all, I'm drawing the key on the right hand side. For carbon, I'm using dot. For silicon, I'm using cross. Sorry, we have chlorine, not carbon. So it must be chlorine. Dot. Silicon. Let's look at their position in the periodic table. Silicon belongs to group 4. So it must have 4 valence electrons. What about chlorine? Chlorine belongs to group 7. It means it must have 7 valence electrons. So silicon will be sharing 1 electrons from the 4 with each chlorine atom. So I will show 1 cross in each circle of chlorine. 1, 2, 3, 4. What about chlorine? There are 7 electrons in their valence shell. 1 electron will be involved in sharing with silicon atom. 1, 2, 3, 4, 5, 6, 7. This one 1, 2, 3, 4, 5, 6, 7. This one 1, 2, 3, 4, 5, 6, 7. This one 1, 2, 3, 4, 5, 6, 7. So this will be the final dot and cross diagram. C, the melting points of silicon tetrachloride and silicon 4 oxide are shown in table 3.1. So we have silicon tetrachloride and silicon 4 oxide. The melting point of silicon tetrachloride is minus 69 degrees centigrade, and silicon 4 oxide, it's 1710 degrees centigrade. Number 1, silicon tetrachloride has a low melting point because it has weak forces of attraction between particles. Name the type of particles that are held together by these weak forces of attractions. It's definitely molecules. So there are molecules in silicon tetrachloride that are held together by these weak forces of attraction. Number 2, explain in terms of structure and bonding why silicon 4 oxide has a high melting point. So it has a giant structure and strong covalent bond. So you write giant structure, strong covalent bond, or many covalent bonds. Strong or many covalent bonds. Question number 4. Hydrogen is produced by the reaction between zinc and dilute sulfuric acid H2SO4. ZnS plus H2SO4 aqueous gives ZnSO4 aqueous plus H2 gas. A student carries out an experiment using excess zinc and dilute sulfuric acid. The student measures the volume of hydrogen produced at regular time intervals using the apparatus shown in figure 4.1. Lumps of zinc are used. Here's the apparatus. These are the lumps of zinc, dilute sulfuric acid, and we have gas syringe in order to collect the gas. The rate of reaction decreases as the reaction progresses. The rate eventually becomes 0. 1. Explain why the rate of reaction decreases as the reaction progresses. So you can mention the concentration of the acid particles decreases or frequency of collision between particle decreases. Concentration of sulfuric acid particles decreases or frequency of collisions between particles decreases. Number 1, explain why the rate of reaction eventually becomes 0. So it's simply all the acid used up or has reacted. All the acid is used up or has reacted. B, the experiment is repeated using powdered zinc instead of lumps of zinc. All other conditions remain the same. Explain in terms of collision theory why the rate of reaction increases if powdered zinc is used. The powder form has greater surface area, the frequency of collisions between particles increases. Powdered form has greater surface area, the frequency of collisions between particles increases. Moving to next part, that's part C. The equation for the reaction is shown. ZnS plus H2SO4 aqueous gives ZnSO4 aqueous plus H2 gas. 25 centimeter cube of 2 mole per dm cube H2SO4 aqueous is added to excess zinc. Calculate the volume of H2 formed at room temperature and pressure RTP. The volume of 1 mole of any gas is 24 dm cube at RTP. Use the following steps. Calculate the number of moles of H2SO4 used. So we have a volume of H2SO4 given as well as the concentration. So you should know that 1 dm cube is equal to 1000 centimeter cube. So you write 1000 centimeter cube contains 2 moles. Therefore, 25 centimeter cube contains X moles. So X is equal to 2 multiplied by 25 divided by 1000. 2 multiplied by 25 divided by 1000. 0.05 moles. Deduce the number of moles of H2 produced. Look at the relation of moles of H2 and H2SO4. It's 1 by 1. So it must be 0.05 moles. Calculate the volume of H2 formed at RTP. Simply multiply number of moles by volume in dm cube at RTP. So you will have 0.05 multiplied by 24. 0.05 multiplied by 24 and we'll get 1.2 dm cube of hydrogen gas. D. Hydrogen can also be produced by the reaction of zinc with dilute hydrochloric acid. Number 1, write a symbol equation for this reaction. This will be the reaction equation, Zn plus HCl. What are the products? We will get hydrogen gas and zinc chloride. For the formula of zinc chloride, you should know the valency of zinc. Zinc has fixed valency, that is +2. What about chlorine? Chlorine belongs to group 7. Here it's in 7. So it must have -1. Ignore the charges. So these subscripts will be exchanged. And finally, you will get ZnCl2. Let's balance the equation. So I will place 2 before HCl. It's balanced now. Number 2, state the test for hydrogen gas. Test is lighted splint and we'll hear pops up squeaky sound or pops up. Question number 5. This question is about electricity and chemical reactions. A. Aqueous copper 2 sulfate is an electrolyte. The electrolysis of aqueous copper 2 sulfate using inert electrodes forms copper at the cathode, oxygen at the anode. Number 1, state what is meant by the term electrolyte. Electrolyte is a liquid. It's usually ionic compound, either in molten state or in aqueous solution that conducts electricity. So you write ionic compound in molten or aqueous. Conducts electricity. Number 2, state the term given to the Roman numeral 2 in the name copper 2 sulfate. Its oxidation number. Of copper here. You have to mention because this number belongs to copper in this name. Number 3, state what happens to the color of the aqueous copper 2 sulfate as this electrolysis progresses. Color fades away or becomes colorless. Becomes colorless or fades. Number 4, write an ionic half equation for the formation of copper at the cathode. Copper gain electron to form copper 2 plus ion gain electrons to form copper metal. So we will balance the equation, 2 moles of electrons. Number 5, give the formula of the ion that forms oxygen at the anode. It's OH negative ion. B, the electrolysis of aqueous copper 2 sulfate is repeated using copper electrodes. State what happens to the anode. So here, if you use copper electrode instead of inert electrode, the electrode will involve during the electrolysis and there will be increase in mass of cathode, and on the other hand, copper anode dissolves because in the solution there will be loss of CO2 plus ion, as CO2 plus ion will get deposited to the cathode, and in order to compensate this loss, the anode dissolves. So you write anode dissolves. C, spoons can be electroplated with silver. Number 1, name the substances used as the anode, that is positive electrode here. So we need to electroplate spoon with silver. So anode should be of silver and cathode should be of spoon. Spoon should be made cathode. What about the electrolyte? You have to take the aqueous solution of silver nitrate or sulfate. Aqueous solution of silver sulfate or nitrate. Number 2, state 2 reasons why spoons are electroplated in order to improve the appearance and prevent corrosion. Improve appearance. Number 2, prevent corrosion. Moving to next part, D. Hydrogen oxygen fuel cells can be used to produce electricity to power cars. Petrol produces carbon dioxide and carbon monoxide when it powers cars. Number 1, state one adverse effect of carbon dioxide and carbon monoxide. Carbon dioxide is responsible for global warming, increased global warming. The reason is that carbon dioxide absorbs thermal energy which is released in the environment and emits some of this energy to the earth. It prevents the loss of energy, heat energy in the space. That's why there's increase in global warming, increase in the temperature of the earth. Carbon monoxide is poisonous or harmful. Poisonous or toxic. Number 2, state one disadvantage other than cost of using hydrogen oxygen fuel cells to power cars compared to using petrol. You need high pressure vessels to store hydrogen. Needs high pressure. To store hydrogen gas. Number 6, this question is about nitrogen and compounds of nitrogen. A. Ammonia is manufactured by the reaction between nitrogen and hydrogen in the Haber process. The equation is shown. This is the reaction. N2 gas plus 3H2 gas gives 2NH3 gas. Number 1, state the source of nitrogen for the Haber process. Nitrogen is obtained from air. Number 2, state the source of hydrogen for the Haber process. It's produced during the cracking of long chain alkanes or from methane. Cracking of long chain alkanes or from methane. Number 3, state the typical conditions used in the Haber process. Temperature is 450 degrees centigrade and the pressure is 200 atm. Number 4, name the catalyst used in the Haber process. It's iron. You can even write the symbol of iron, that is Fe. Number 5, state what is meant by the term catalyst. It's of 2 marks, so you will mention a substance which increases the rate of reaction and remains unchanged at the end of the reaction. A substance that increases the rate of reaction. It remain unchanged at the end of the reaction. Part B, ammonia is converted into nitric acid. Number 1, the first stage is the conversion of ammonia into nitrogen monoxide, NO. The equation is shown. This is the equation. 4NH3 gas plus 5O2 gas gives 4NO gas plus 6H2O gas. The reaction is carried out at a temperature of 900 degrees centigrade and a pressure of 7 atm. The forward reaction is exothermic. So for your convenience, I am writing the sign of delta H. It must be minus in the forward direction. And if the forward is exothermic, backward should be endothermic. So the sign for delta H for the backward direction should be positive. Using explanations that do not involve cost, explain why a temperature less than 900 degrees centigrade is not used. So it will decrease the rate of reaction. Decreases the rate of reaction. Explain why a pressure greater than 7 atm is not used. So what will happen if you increase the pressure? The equilibrium will shift to the side with less number of moles. And if you count the number of moles of gases in the equation, on the reactant side, you have 9 mole of gases. And on the product side, you have 10 moles of gases. So you can't have greater pressure. So the equilibrium will shift to the reactant side. Position of equilibrium. Equilibrium shifts to left hand side or reactant side. Number 2, in the second stage, nitrogen monoxide reacts with water and oxygen to produce nitric acid. Balance the symbol equation for the reaction. Here's the equation. We have the reaction between NO plus O2 plus H2O gives HNO3. So in order to balance the number of atoms of each element, so first we'll start with 2. Let's place 2 before HNO3. Hydrogen is balanced. What about nitrogen? I will place 2 here. Now, how I can balance oxygen? On the right hand side, we have 2 multiplied by 3, 6 oxygen. And on the reactant side, we have 2 plus 2 plus 1, 5. So we can't balance it by placing 2 here, because then it will become 2 multiplied by 2, 4, 4 plus 2, 6, 6 plus 1, 7. And I can't place 3 also before HNO3. So let's place 4 before HNO3. Now I have to place 2 before H2O. What about nitrogen? I have to place 4 before NO. Now let's balance oxygen. On the right hand side, we have 12 atoms of oxygen. Oxygen 12. On the reactant side, it is 4 plus 2, 6. So we need 6 more oxygen. So I have to place 3 before O2. Now this equation is balanced. C. A student makes aqueous copper 2 nitrate by adding an excess of solid copper 2 carbonate to dilute nitric acid. Number 1, write the symbol equation for this reaction. You have CuCO3 and it is added to dilute nitric acid. So we have HNO3 for nitric acid. And you want to make copper 2 nitrate. So the formula for copper 2 nitrate, if you want to predict the formula, you have Cu and NO3. Cu is carrying plus 2 charge here. What about NO3? NO3 carries minus 1. Ignore the charges. Subscripts will be exchanged and you will get CuNO3 whole twice. This is reaction between metal carbonate and acid. So the other product should be water, H2O, and carbon dioxide, CO2. Let's balance the equation. We simply place 2 before HNO3. Now it's balanced. Number 2, state 2 observations that indicate the copper 2 carbonate is in excess. No more solid dissolves and the bubbling stops on further addition of copper 2 carbonates. No more solid dissolves or undissolved solid, and bubbling or effervescence stops. On addition of more copper 2 carbonate. This indicates that copper 2 carbonate is in excess. Number 3, name one compound other than copper 2 carbonate that can be added to dilute nitric acid to produce aqueous copper 2 nitrate. You can take copper 2 oxide or copper 2 hydroxide. Copper 2 oxide or copper 2 hydroxide. Moving to next part. Question number 7. This question is about organic compounds. A. Propane and chlorine react at room temperature. An equation for the reaction is shown. This is the reaction. C3H8 plus Cl2 gives C3H7Cl plus HCl. Number 1. State the condition required for this reaction. It needs ultraviolet light to take place. Number 2, draw the displayed formula of two structural isomers with the formula C3H7Cl. So they are talking about the isomers with the formula C3H7Cl. So the isomers must be having different positions of Cl in them. So one must be 1 chloropropane and the second must be 2 chloropropane. For your convenience, I am writing their name. 1 chloropropane and we have 2 chloropropane. The difference is in the position of chlorine. We have 3 carbon atoms here. 1, 2, 3. In 1 chloropropane, we have to place either on the right hand side or left hand side. We have to place chlorine on the right hand side or the left hand side. Let's consider this carbon as number 1. 1, 2, 3. Now I am saturating the carbon atoms with hydrogen. What about 2 chloropropane? Again, we have 3 carbon. 1, 2, 3. I'm counting from right hand side. 1, 2, 3. This time I'm placing the chlorine on the second carbon, Cl. Now let's saturate the carbon with hydrogen. So these two will be the final formula for the structural isomers with the formula C3H7Cl. P. Alkenes are a homologous series of hydrocarbons. One state two characteristics that all members of the same homologous series have in common. So they have same general formula, same chemical properties, same method of preparation. They have same or common functional group. So you'll write any two from same general formula, same functional group, same chemical properties, same or similar method of preparation. Two, addition polymers are made from alkenes. Complete figure 7.1 to show one repeat unit of the addition polymer formed from but-2-ene. So we need to show one repeat unit of the addition polymer formed from but-2-ene. So first of all, I'm going to draw the displayed formula of but-2-ene. We have 4 carbon atoms in but-2-ene. We have 1, 2, 3, 4. And there must be double bond between second and third carbon atom. It's up to you whether you can start counting the carbon atom from the right hand side or left hand side. You must have double bond between these two. Let's saturate the carbon atoms. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. I will place hydrogen. Now, in order to make the polymers, I can draw this butene in this way. It's better if you draw in this way, then you can draw the monomer produced during the polymerization will be easier for you. Now, for the polymers, you simply have to remove this double bond and add up two single bonds on the right and left hand side. This will become the repeat unit for butene. So for this we have CH3, CH3, H, H. So this will be the repeat unit obtained during the addition polymerization of butene. C. A repeat unit of a condensation polymer is shown in figure 7.2. The polymer is made from two monomers. This is figure 7.2 and we have the condensation polymer. Number 1, draw the structures of the monomers used to produce the polymer in figure 7.2. So first of all, I have to pick the monomers. Before that, I have to pick the repeat unit for this one. If you look at the formula carefully, so the repeat unit for this one should be this one. This one will be the one repeat unit and this one will be the second repeat unit. Now I'm drawing the repeat unit for this on the left hand side. So we have C double bond O, CH2, C double bond O, bond. Now what else you will place in order to get the monomer? Because it's a condensation polymer, so it must be having OH group at the end on the both sides. What about the other monomer? It must be O, bond CH2, CH2, bond O, place H. So this will be the final structure of the monomers used in this. Number 2, name the type of condensation polymer in figure 7.2. If you look at this condensation polymer, if you look at the linkage, this linkage is ester linkage. So it must be polyester. Number 3, name the two homologous series to which the monomers in one belong. Look at the monomers. If you look at the functional group in this one, you have carboxylic group. These are carboxylic group, carboxylic acid. What about this one? This one belongs to alcohols. So we have carboxylic acid and alcohols. Carboxylic acids and alcohols. Thanks for watching. Press like and share my videos. For more videos, subscribe to my channel and press the bell icon.